I'm going to have to run through this super fast because I'm not sure how much battery life I have. No, I'm just kidding. So I've been programming for about 30 years now, and I've been doing it professionally for about 20 years, a little more than that. In that time, I've written a lot of so-so, middling, average code. I've written some bad code, and I've written some good code. But the software that I'm proudest of, the good stuff, is the stuff that gets reused by other programmers all the time. Some of it's in the Python standard library and is used by, I have no idea how many people all around the world every day. Some of it was written in a lab up the hill at McGill 15 years ago and is still used in a handful of scientific labs around the world. And that's pretty cool too. It doesn't really matter if it's used by tens of programmers or thousands of programmers. I'm very happy with the result. But nobody ever told me how you go about writing code that's useful to other programmers. I've figured a few things out on my own. I've read some books. I've done a lot of dumb code and learned a lot of mistakes. Talked to people, read blog articles, and I've just been kind of figuring it out. And I realized recently, I've been figuring it out for 20 years now. Maybe I've learned a few things that I should share. So as a way of background, I want to take you back to the beginning of my career in the early 90s. Oh, wait, sorry, wrong early 90s. This early 90s. When the world was full of books and magazine articles extolling the brave new world, the golden era that was soon to dawn if you would only embrace this wonderful new technology of Fortran 95 or Java or C++ or whatever the particular advocate was advocating. If you'll just drink the Kool-Aid, switch to this wonderful new paradigm of object-oriented programming, everything will be great. We'll all start writing reusable software, and that will fix all of our problems. So strangely enough, millions of programmers did drink this Kool-Aid, and they drank it, and they drank it, and they drank it, and eventually it started to taste good. And after 15 years of drinking this Kool-Aid, somebody sat down one day, some fine programmer, probably a very smart person, and decided that it would be a good idea to write a class called AbstractSingletonProxyBeanFactory. And you can read in the documentation for this class that it is a convenient proxy factory bean superclass for proxy factory beans that create only singletons. If you understand that sentence, you could have a bright career as a Java programmer. If you don't understand that sentence, good, keep it that way. This is not reusable code. This is object-oriented madness. And I'm not here to bash object-oriented programming, even though it's fun and can be easy. I'm not here to bash Java programmers either, even though that's fun and kind of easy. I am here to point out that a good 5, 6, 7 years before the craze for object-oriented programming in the early 90s, a fellow called Fred Brooks wrote this article in which he claimed that there are no silver bullets. There's no single amazing, wonderful miracle technology that will usher in a golden era of massively enhanced productivity or reusable code or extensible code. It ain't gonna happen. It's not object-oriented programming, it's not aspect-oriented programming, it's not functional programming, it's not whatever the flavor of next week is going to be. There are no silver bullets. Instead, writing reusable code is like all the other good things in life. It's hard, it's not free, there's no magic pixie dust. It requires forethought, it requires a great deal of attention to detail. Sorry. Okay, is it really important to write reusable code? I mean, there's a lot of software in the world that just does one thing. You're writing one application, you need to fix this implement this one feature today. Does that have to be reusable code? No, probably not. There's nothing wrong with code like that. In fact, the best reusable code starts out like that, and then gradually you realize, hey, if I just change this and this, it's a little more general and I can reuse it in other contexts. Nor does it have to be in the Python standard library or the Go standard library or the Java standard library. It might just be a library that's used within your organization. It might just be a little module that's widely used within one application. There are degrees of reusability. And there is such a thing as perfectly fine, wonderful, beautiful code that does one thing for one application. It's really not reusable, and there's nothing wrong with that. But given that caveat, the rest of the talk is about how to write reusable code at whatever level, whatever context. I am not a super genius. I never even thought about doing a PhD. I'm just an ordinary programmer. If I can do this, you can do this. And hopefully, I can save you some of the dead ends and false starts that I've gone down over 20 years of doing this, 20-odd years of doing this. So learn from my failures, learn from my successes, and here are some principles of writing reusable code. I came up with a list of 9. I could probably do more, I could probably do less, but it happens that 9 fits nicely on this slide. It also fits reasonably nicely in a 30-minute talk. So I'm not going to insult your intelligence by just reading this list at you. Instead, I'm going to insult your intelligence by reading the individual bullet points on the 9 following slides. No, just kidding. So first, it doesn't matter. I mean, yes, for whatever kind of programming you do, just be a better programmer. And that means writing, whether you're writing a library for the whole world or a library for your team of 6 or 7 programmers, be a better programmer. And the way to do that is to write more code. Obviously, you get better at something when you do more of it. But as you write your code, critique it mercilessly, refactor it ruthlessly. Don't just say, oh, that's good enough, that'll do. Make it better. Another important thing, which I don't think we generally do enough of, certainly I wasn't taught this in school 25 years ago, is to read more code. In particular, read code from the real world, software that actually does stuff. This third book that I've shown the cover of, Beautiful Code, came out a couple of years ago, and it's kind of built on the idea of, well, gosh, you know, if there's nice software out there in the world, we should study it and learn from it. So far, I'm only about halfway through the book, and it's wonderful. Highly recommended. The other 2 are also really good books to read about programming, because, well, that's my third point, is read more books. Specifically, read more books about programming. Nothing wrong with Moby Dick, but I'm not sure it'll make you a better programmer. These 3 books will make you a better programmer, and there are lots of other books like them. I'm particularly fond of these 3 because I'm plowing my way through 2 of them currently. Finally, you're not going to learn to program from Google, or you're not going to learn a whole new language or a whole new library from Google. Enough said on that. Point number 2, don't write a class where a function will do. Most of us these days are writing in languages that have object-oriented features, and that's great because object-oriented programming is a nice technique. It's a good trick to have in the toolbox. I'd rather have it than not have it. But a lot of people learn this, either they learn this new technique and say, oh, I must apply this technique to every problem, or they're stuck using a language where it is the only technique. So people tend to overdo it a bit. On the other hand, if you have a collection of functions that really are related and have some shared state, well, that's a class whether you call it one or not. So don't be afraid of classes. Just keep in mind, a class is not always the right answer to a particular problem. Here's a very simple example. I need to load things from a particular host by ID. A scary number of programmers have a default action of writing something like this. If I need to load things, well, then I need a thing loader, obviously. Oh, sorry, my cell phone is yelling at me. I knew I should have turned that alarm off. So this is a code smell. This is a particularly bad code smell. A class with exactly 1 method in it is a very, very bad code smell. A class with exactly 1 public method, you can make a case either way. If this had 600 lines of intricate code split up into 17 private methods, I would say, yeah, okay, we can get away with a class with a single public method, but it doesn't. This is a class with 1 method. Why is this a class at all? Why not just write this? This is my 2-slide, 30-second summary of a talk given by Jack Diederich at PyCon a couple of years ago. Well worth looking up. It's a very entertaining and educational rant, which are the best kind. I'm going to repeat these links at the end of the slides, or the end of the talk, so don't worry too much about getting everything Now, the converse of that, or the inverse of that, I'm never sure which is converse and which is inverse. Some people will hear that advice and say, okay, I'll never write another class again. No, it's a useful technique, it's a useful tool. And in fact, if you have a collection of functions that do stuff over a connection to a database or whatever, I don't know, and they do stuff over that connection relating to articles, they load articles, they save articles, they look up attributes of articles, well, that's a class. And this particular pile of code doesn't make it look like a class because I'm not using that feature of my imaginary programming language, but that's a class. And it will be, your code is clearer, it states your intention better if you just use the syntactic features of your language to say, this collection of functions are actually methods that together comprise a thing called an article store. Cool, great. I mean, it's not a massive epiphany, it's just a convenience, but it's a good convenience. It's a nice feature to have. So 25 years ago, I was in undergrad, starting out, taking some computer science courses for the first time, and the default teaching language back then was Pascal. Pascal has since been superseded by newer, hotter, cooler languages, but I think we lost something when we stopped teaching Pascal. Pascal has this weird feature, I'm not aware, maybe other languages in that family like Modular had it, I really don't know, had this weird feature that it has procedures and functions, and they're different things, they're declared differently, and they have different rules. And the rules are very simple. Functions compute stuff, procedures do stuff. If you're into functional programming at all, this is completely obvious. Functional languages like Haskell take this to an even greater extreme, which I cannot explain to you because I don't really understand Haskell. But even if you're using one of the mainstream imperative languages like Java or C or Python, unfortunately, they don't care about this distinction between procedures and functions. To all the mainstream imperative languages, a function's a function, and some of them happen to return nothing, or void, or whatever you call it. That's unfortunate, because you should care. I follow a really simple rule of thumb, which is every function should either return a value or have a side effect. Try really, really hard to avoid writing functions that do both. There's nothing wrong with side effects. Side effects are part of life, but try to segregate them. Have your side effects off in separate functions that don't compute stuff. It's a rule of thumb. It's not an ironclad, carved in stone, thou shalt not commandment. And in particular, it can be quite difficult to get fast code or avoid duplicate code while following this rule of thumb. So, sometimes I break it. But I like to know when I'm breaking it, and I like to break it only in special circumstances. So here's an anti-pattern. This is the kind of thing that C programmers are notorious for, because C programmers are obsessed with performance. So this is an imaginary function in an imaginary language that's kind of like C, where you're given a string and you modify the string in place. You do some simple processing on that to that string, and you return a value derived from that mutation. The number of E's changed to uppercase, or whatever my silly example was. And this is a fast way to do it, which is why C programmers just love it. However, it's really hostile to reuse. It just makes this function harder to reuse. If you care about making this particular function reusable, you're going to sacrifice a bit of performance. Hopefully, you're going to use a language that supports multiple return values. If you're not, it gets really contorted and ugly. It's the same idea conceptually, but the idea is you don't mutate the string in place and return something about that mutation. You return a new string, which is a transformation, and you can also return the computed value. And yeah, it's less efficient. You have to allocate a new string. Sue me. It's much more reusable. And generally, reusability should trump performance. Not always. There are times when performance wins, but I prefer this as the default. So reusable code is generally categorized into two types of things. There's libraries and there's frameworks. And for some reason, hardly anybody explains what a framework is when they said about writing frameworks or talking about frameworks or playing with frameworks. It's actually pretty simple. A library is something where you the programmer using the library is in control. You decide which bits and pieces of the library you're going to call and which bits and pieces you're going to leave on the floor because you're not interested in them. With the framework, the relationship is inverted. The framework is in control. You have to write a pile of code that conforms to the rules of this framework and submit it to the great God framework and say, oh, framework, please won't you execute my code just as I hope you do. And if you're lucky, it all works out. Typically, frameworks are all or nothing. It's really, I mean, the classic case is, I'm looking at 3,000 lines of framework, and hey, there's a 20-line function. Oh, it's not a function. It's going to be a method. Buried in that framework. That's all I want. I just want that 20-line function because it solves exactly the problem I've got right now here today. But I can't, because it would be more trouble to write my code in such a way that somehow that useful 20-line function gets called when I need it. It's way more trouble than it's worth. So, you know, honestly, what's going to happen in the real world, somebody's just going to copy and paste those 20 lines of code into their application. Blah. That's not reuse, that's copy and paste. Anyway, over-reliance on frameworks hampers reuse. Good frameworks have a bunch of functions scattered throughout them that you can just, you know, call without using the rest of the framework. So for all of the above points, it is possible to go overboard, like the hypothetical programmer who watches a talk on YouTube about stop writing classes and says, all right, I'm never going to write another class again in my life. No, classes are a great tool. Object-oriented programming is a really handy trick to have in your toolbox. Like I said, I'd rather have a language with objects and classes than a language without. Side effects, so classes are not evil. Side effects. Side effects are not evil. If you take a nuts and bolts engineering view of computation, a computer is just a big box of numbers with some wires going in and some wires going out. So every computation is a side effect. Of course, the Haskell weenies say, no, computation is math. It's all pure functions. And yes, you have to have some side effects because you have to write some values onto those wires going out of the box of numbers, but computation is math. Yeah, okay. Yeah. It's a fun argument, but you know, they're both valid views. Just the point is, try to keep your you can't avoid side effects, but try to keep them segregated, keep them distinct from functions that compute values. You got functions that do stuff and functions that compute stuff. Try to keep them separate, unless you really can't for reasons of performance or code duplication. It's a balancing act. Do I want reusable code or do I want fast code? They're not always compatible. Finally, certain problem domains, I'm thinking of web development, really call out for constraining the application developed to a particular garden path. This is the known good way to write web applications, and here's a framework that will pretty much force you onto that garden path. That's a good thing in the particular case of web development, because there's so many finicky little details that you have to repeat every time. So many things you can go wrong, that can go wrong, and when they go wrong, you have a security hole, and that's not good. So that's why web frameworks are a dime a dozen, and 16 people have sat down to write a new framework in the given time I've been giving this talk, probably. Oops. So, next point. Do not try to solve every problem in your library, because you won't. You're only human. You're going to miss something, or you'll get something wrong. So if you're not sure about whether to implement a bit of functionality, it's better to leave it out. And the logic behind this is really simple, because remember, if you're writing a library or a framework, if you have to, who's going to be using that? Other programmers. And if there's something missing from that library or framework, who is capable of writing the code to provide that functionality? Other programmers. So there's not really a problem here. Your users might complain, hey, you didn't implement this feature, you didn't implement that feature, but they're programmers. They can implement it if they need to. On the other hand, if you put in too much functionality, not too much functionality, but if you put in a bit of functionality and you get it wrong, it's ruining my day because there's some nasty, horrible code in your library that's just breaking my ability to use your library. Well, who can fix that? Nobody, typically. Either I'm, as the user, I can't fix it because it's your library, and in the worst case, you can't fix it because if you do, it's going to break the compatibility. Some other user who's relying on that ill-advised piece of code, you're going to ruin their day. So honestly, it's very often better to leave stuff out than to put it in. It's definitely better to leave something out than to put in a bad implementation. Testing. If I was giving this talk 20 years ago, well, first of all, I wouldn't know any of this stuff, but I would have had to work really hard to convince you that you must write automated tests. Because 20 years ago, the tools were not that great. Pretty much everybody had to write their own test framework, which is why software that's been around for 20 years all has its own test framework. That is not the case anymore. In 2015, there is no excuse for not writing automated tests, especially for libraries and frameworks and that sort of thing. If you give me a library that has no tests, then that tells me you have no confidence in your own code. And if you don't have confidence in your own code, how on earth can I have the confidence to use it? There's no controversy. There's no need for debate or discussion. You must write tests. Really, I mean, the debate and the discussion nowadays is, well, can we stop at 90% coverage, or should we really strive for 100% coverage? I think that's where the debate is these days. Documentation is a little bit of a harder sell, and honestly, the tools that we need for documentation don't quite exist yet, at least not in the languages I'm most familiar with. We have good tools for writing inline reference documentation, whether it's JavaDoc or docstrings in Python or GoDoc or blah, 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 blah. Pretty much every modern language has some sort of facility for writing and nicely formatting inline reference documentation. Therefore, that is the bare minimum. You must write inline reference documentation for public functions, classes, modules, and so forth. You can't get away with anything less than that. But really, you need more than that. You need some nice narrative prose documentation with hand-holding examples, and here's what to do, and here's the easy way, and here are the obscure bits that you probably don't need in your first couple of days with this library, et cetera, et cetera. Stuff that you just can't find from inline reference documentation. Finally, this is not a talk about extensible code. This is a talk about reusable code. The snake oil salesman from the early 90s at least had the decency to use to sell us on a brave new world of extensible, reusable software components. At least they used two separate words, recognizing that those are two separate concepts, two different properties of software. Something can be extensible and not reusable. It can be reusable and not extensible. If you know how to write extensible code, you should be up on this stage giving a talk. I'd love to hear that, because I haven't figured it out yet. So those are my 9 principles this week. Ask me again next week. I might have different principles, more, fewer, I don't know. It really boils down to that there ain't no such thing as a free lunch. Anything good in life requires hard work, and that includes reusable code. There's no magic pixie dust. There are no silver bullets. And there's kind of a side note in there that, you know, beware of pompous windbags and clueless pontificators. Any idiot can put a blog post on the internet or a magazine article in print and try to sell you on the hot new thing of the day. There are no silver bullets. Oh yeah, any idiot can also stand on a stage at a conference, but forget that. Anyway, so these are some of the books, articles, talks that I referenced if you're interested.